This next section is about multiplying rational expressions. So we're going to take these functions that we've been studying and now work on doing operations with them. And the first operation we're going to do is multiplication. I want you to be aware of some language. Product is the answer when we multiply. So if you see that word, that means you will be multiplying and you're listing the answer to that question. All right, so before we get started with actual multiplication, I also want you to be able to state the domain of your product. So the domain of a rational expression is going to be everywhere that the denominator is not 0. So it's going to be all real numbers except for maybe a list of numbers that doesn't work. So just like finding the vertical asymptotes, we're going to look at our denominator and set that equal to 0. So x squared minus 9 is equal to 0. And I see x squared minus 9 as a difference of two squares. A is x and b is 9. So I can write this as b squared is 9. B would be 3. So I can write this as x plus 3 times x minus 3 because it's a difference of two squares. And then I can set each of those factors equal to 0. And I get x equals negative 3. So that's one way that the denominator would be equal to 0. And x equals positive 3 would be the other way that the denominator is equal to 0. So the domain for this example would be all x's such that x is not equal to negative 3 and x is not equal to 3. That's where this function would have vertical asymptotes, so it doesn't have a value at those points. All right, so our first example, we're going to write an equivalent expression. We're also going to say the domain of that expression. So the first thing we're going to do is factor the numerator and the denominator. All of our factoring skills that we've done so far are going to come into play. I just want you to know that there is a typo on my notes here. The typo is not on your note sheet, but there is a typo on my notes. All right, so I'm going to start with my numerator. I'm going to factor out an x. So I get x squared minus 5x minus 24. I just noticed that every single term in the numerator had an extra x in it, so I could factor an x out. I noticed that that's also true in the denominator, so I can take an x out of the denominator as well. This one has an x cubed, this one has an x squared, that one has an x, so I can divide all of those terms by x, and I have x squared plus x minus 72. And now I'm looking at factoring those quadratics. I notice that I need numbers that multiply to 24 and add to negative 5. Oh, actually, they multiply to negative 24. So I'm thinking like 2 and 12, but that would add to be 10 or negative 10. I'm thinking 4 and 6, but that wouldn't add to give me a 5. So how about negative 8 and 3? So then I'm going to factor this, so it would be x times x minus 8 times x plus 3. I can do that factoring because I noticed that there's a 1 in front of the x squared, so I don't have to do the whole x box method. All right. So for my denominator, I noticed that I'm looking for numbers that multiply to give me 72, negative 72, and they add to give me a positive 1. Well, I know that 8 times 9 gives me 72, and I also know that they're 1 apart, so if I make the 9 positive and the 8 negative, that would work. Okay, so now I've factored my numerator and my denominator. Now I'm going to look at my function, and I'm going to write the domain. So the domain is going to be all x's such that x is not equal to negative 9, x is not equal to 8, and x is not equal to 0, because all of these values would result in a 0 in the denominator. Okay. Now we're going to look at our function and we're going to divide any common factors to make 1. So x divided by x would make 1. And x minus 8 divided by x minus 8 would make 1. And so we're left with an equivalent expression of x plus 3 over x plus 9. This expression is equivalent as long as x doesn't equal -9, 8, or 0. And so that's our equivalent expression. Here's one for you to try. Go ahead and pause the video at this point so you can do that same process with this problem and unpause when you have tried it. Okay, for this problem, our domain can't be 0 because 2x to the 4th would be 0. It can't be -7 because that would make x plus 7 0, and it can't be 7. And then when we divide common factors, we get 3 times x plus 1 and 2x times the quantity of x plus 7. All right, so in this example, we are going to do that same process, except after we do that, we will also simplify our expression. So to start with, we will factor the numerator and the denominator. I notice that the numerator is a difference of 2 squares. So I'm going to use 2 plus x and 2 minus x. And I notice that the denominator has 2 numbers that multiply to make -10 and add to make 3. So I'm going to use +5 and -2. Now I notice that these two factors are almost exactly the same thing, but not quite. And so I can't quite divide those to make 1, but I can change the signs on one of them so that it looks more like that. So I could say, well, this is 2 plus x, and then I'm going to take a -1 and take -2 plus x. Notice how if I multiply that -1 through the parentheses, I get the same thing that I had before. So I haven't really changed anything. I just wrote this a little bit differently. So then I have x plus 5, and I notice that this term is the same thing. It's -2 and +x. So now those two terms can divide and make 1. Our domain is going to be all x's such that x is not equal to -5, because that would make this factor equal to 0, and x is not equal to 2. So that's our domain. And then our expression, after we cancel any terms that are the same, would be -1 times 2 plus x over x plus 5, because these can cancel. And then we're going to simplify by multiplying that -1 through. So I have -2 minus x over x plus 5. And this expression is equivalent to our original expression as long as we are on the restricted domain. All right, so here's one for you to try. Go ahead and pause the video and then come back after you have given it a try. So after factoring the numerator and the denominator and getting things to cancel or divide to make 1, I'm left with x plus 1 over x squared minus 3x. And my domain has to be any place where the denominator of the original function would be 0. So it's all 3 of those places would be restricting the domain. All right. Now we're finally ready to actually multiply. So what we're going to do first is we're going to factor every term. So I'm going to write this as 5x, which is already factored. And then I have x squared plus 1x minus 6. I'm going to write that as x, and then 3 and 2 multiplies to make 6. And adds to make +1 as long as the 3 is positive and the x is and the 2 is negative. And then for the last term, I have a common factor of x, so I can write that as x times x plus 1. And then in the denominators, I have x plus 3. And then this 1 multiplies to make 1 and adds to make 2, so that would be 1 and 1. And then the last one has a GCF of 5, so I can take a 5 out and I have x minus 2. Now I'm going to divide common factors and make 1, so x plus 1 divided by x plus 1 would be 1. And what else do I have? Oh, x minus 2 times x minus 2 would make 1. Oh, and 5 divided by 5 would make 1. And x plus 3 divided by x plus 3 would make 1. So now looking at what's left, I have x squared, because I have 1 times x times 1 times 1 times x times 1. Oops. And then in the denominator, I have x plus 1. Now my domain is going to be any 0 in the denominator, even the ones that I canceled. So I have x can't be equal to negative 3, x can't be equal to negative 1, and I have a negative 1 again, so I'm not going to list that one again, and x can't be equal to 2. All right, this is the last one for you to try, and then unpause the video when you're done and check your answer. All right, so noticing that almost everything canceled out, I was left with just a 1 in the denominator. That's why I've been really stressing that these divide to make 1 so that you know that you have a 1 in the denominator. That's okay. And then you also have a negative 1 because you had to change the signs on this x minus 9, so it would cancel with a 9 minus x. So then we're left with negative x plus 4. And then the restricted domain includes even the factors that we canceled out. So x can't be 9, negative 4, or negative 10. All right, thank you so much. Good luck on your work.